Welcome to Homework Lib.
Here's a review of the Bohr model of the atom. And what this Bohr model addresses is a very interesting thing about the hydrogen spectrum in the visible wavelengths. So the Bohr model was developed to address some features in the hydrogen atom, specifically its emission and absorption spectra. What was noticed is that there was a regular sequence of colored lines that hydrogen produced in the visible spectrum. And a scientist by the name of Balmer developed a mathematical relationship that you could essentially reproduce those emission lines by taking the difference between a 1 over n1 squared minus a 1 over n2 squared, where n1 and n2 are both integers, two different integers. What Bohr did is he took the ideas of quantum physics that were getting developed, and he developed a model of the hydrogen atom that had at its heart a positive proton in the nucleus and an electron in orbit about that nucleus in a circular orbit. But what he did is he quantized the angular momentum of that electron. So there's a classical model that you can develop for that electron that involves the force of electricity between it and the nucleus as a function of the distance squared, the Coulomb's law essentially, and uses uniform circular motion to equate that force to a centripetal force. But what he added was a quantized angular momentum. That is, that the electron has some sort of wave associated with it that has to repeat itself as you complete a full circle. And there are nodes and antinodes to that wave. But what this meant is that if you put it back into the dynamics, you find that the electron has quantized orbits. Orbits depend on an integer n. And the energy levels also depend on integer n. So both kinetic and potential energies of that electron then become quantized, and there are energy quantized levels inside the atom. And interestingly, so I'll just kind of show that energy level diagram, the energies depend on a specific constant value of minus 13.6 electron volts divided by n squared. So as you start at n equals 1, the spacing starts out large, and then it gets smaller and smaller. And what was seen with this model is that it correctly predicted the wavelengths of light in the Balmer series. So notice that Balmer independently figured out this 1 over n squared dependence. And now Bohr had an explanation for that the energy levels and hence the orbits of the electrons were becoming quantized as well. So the Bohr model correctly predicted the main features of the spectrum of hydrogen, and it did so by quantizing the energy levels inside of the hydrogen atom. And that's the extent of what the Bohr model did.